episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
All right, welcome everybody again to another episode of our show with another truly fascinating guest who is involved in creating a better tomorrow and a better future for all of us. We have the honor today to be joined by Professor Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University, which he joined back in 1993, originally as assistant professor in the Department of Astronomy, and he was tenured only 3 years later. Dr. Loeb received his PhD in plasma physics from the Hebrew University of Jerusalem at the age of 24. He led the first international project supported by the Strategic Defense Initiative and was subsequently a long-term member of the Institute for Advanced Study at Princeton. Dr. Loeb has written 8 books, including most recently Extraterrestrial, the first sign of intelligent life beyond Earth, and about 800 papers on a wide range of topics, including black holes, the first stars, the search for extraterrestrial life, and the future of our universe. Dr. Loeb has been the longest-serving chair of Harvard's Department of Astronomy, founding director of Harvard's Black Hole Initiative, and director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. He serves as chair of the board on physics and astronomy of the National Academies, an elected fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. Dr. Loeb is a member of the President's Council on Advisors on Science and Technology at the White House, and a member of the advisory board for Einstein Visualize the Impossible of the Hebrew University. He also chairs the advisory committee for the Breakthrough Starshot initiative, serves as the science theory director for initiatives of the Breakthrough Prize Foundation, and in 2012, Time magazine selected Dr. Loeb as one of the 25 most influential people in space, and in 2020, Dr. Loeb was selected among the 14 most inspiring Israelis of the last decade. Dr. Avi Loeb, thank you for taking the time out of your schedule to come join us today.
Thank you for having me.
It's a real pleasure. As we typically do, I would love to give you the floor just for a few minutes to introduce yourself, take us back to sort of the early days when you first got interested in this domain. And as a part of that, as we have had the honor to interview people on the show from groups like the Air Force Research Laboratory, the Office for Naval Research here in the U.S., and talk about some of the dual use interests, I'd be very interesting to hear how your early experiences in the Talpiot program in the Israeli Defense Forces and, of course, the Strategic Defense Initiative got you interested in thinking about sort of the greater cosmic interest that you have today.
Right. So if I start from the beginning, and in fact, my current way of thinking is not very different from the beginning. I was born on a farm in Israel, in a village, Moshav, where my family owned the farm, and I collected eggs every afternoon and used to drive the tractor to the hills and read philosophy books. I was interested in the deepest questions. And the problem with philosophy, although it's an extremely important discipline that raises the most fundamental questions that we have, it rarely offers clear answers to these questions, and there are debates throughout the history of philosophy. But I was extremely interested in this, and if I was free to pursue my interests, I would become a philosopher by now. However, I had to serve in the military, and I preferred to do intellectual work, and that led me to physics, because I was good in physics, but recruited to the benefit of the defense of Israel into a program called Talpiot, where I finished my PhD at age 24 in physics and mathematics. And the research was dedicated to plasma physics, the physics of very hot gases. I didn't know anything about astrophysics, but I led a project that was the first international project to be funded by the Star Wars initiative of Ronald Reagan in the mid-1980s. I remember General Abramson visited Israel, and we presented the project, and he selected it as the first international project, and that brought me to Washington. And then in one of the visits to Washington, D.C., I went to visit also Princeton, the Institute for Advanced Study there, and was offered later on a 5-year fellowship there under one condition, that I'll switch to astrophysics. This was a gamble that John Bacall, an astrophysicist there, took. He liked Israelis and he was married to an Israeli. And he asked about me and decided to offer me this position, which in retrospect looks like a big gamble. Today, I would not be able to make such a decision because there are selection committees for any position that we offer. Back then, he was able to do that on his own. And that brought me to astrophysics. I didn't know how the sun shines. I mean, it was very embarrassing and humbling to start in a completely new field. But since I was given this opportunity, which is quite rare, also for practitioners in the field, I was delighted to accept it and try that. And it always felt like an arranged marriage where someone else gave you a bride and you don't have the freedom of actually going in and marrying your true love, which in my case was philosophy. But then there was a position at Harvard University and a junior faculty position that was advertised. I was encouraged to apply. I applied to it. They selected someone else, and that someone else decided not to take it because the chance of getting tenured are small. And so I was given it. I wasn't really afraid about not getting tenured because I could always go back to the farm, which was plan B. And even now, it's not clear to me that being a farmer would be a bad career choice. You know, it's very relaxing to be embedded in nature rather than academic colleagues, which are not necessarily as relaxing. But I ended up being tenured after 3 years. And at that point, you know, I realized that actually I'm married to my true love in a way, because there are philosophical questions in astrophysics that we can address. For example, how the universe started. You know, that question is raised in the first chapter of the Old Testament, the Bible. Obviously, it was of philosophical interest for a broad audience, the public at large. And now we can address this question scientifically. That's quite exciting. Also, the question of how did life start and whether it exists elsewhere, which again appears in the first chapter of the Bible. And this is a question that astronomers are now addressing. So in a way, and also how the first light was produced, let there be light. That is actually a research frontier that I pioneered early on a couple of decades ago. So altogether, I'm very happy being married through an arranged marriage that ended up being to my true love. And the interest in the search for life elsewhere came about by chance. I was mostly working on black holes and on the early universe, how the universe started. But then one of the ways of mapping matter early on in the universe, mapping hydrogen, was to detect radio signals from hydrogen. And I worked on that, and then there were observatories, radio observatories constructed to detect that radio signal. And the main obstacle ended up being interference from TV and radio broadcasting on Earth. So then it hit me that, you know, if we have interference from radio broadcasts on Earth, perhaps we can also search for, we can eavesdrop on radio signals from other civilizations. That was my first paper, my first encounter with the search for extraterrestrial intelligence. And then after a few years later, I started thinking, I actually was invited to a conference in Abu Dhabi. NYU had a new campus there. And when we went there, I went on a tour where the tour guide was bragging that the city lights of Dubai and Abu Dhabi can be seen from the moon. And then it raised the question. I thought to myself, oh, well, how far can a big city be observed with our telescopes. And it turns out that, for example, Tokyo, the city of Tokyo, can be seen all the way to the edge of the solar system. And so I wrote a paper about that. And then I thought about industrial pollution. It was the time of the Obama administration where there was a lot of talk about the climate change from industrial pollution and so forth. And I asked myself, is it possible to detect it on a planet around another star, looking for industrial pollution? So I wrote a paper about that with a student of mine. And then after that, I started writing I started getting really engaged in this subject. So as you can tell from this brief description, it wasn't something that I thought about for many years. It sort of evolved into the interest that I have right now.
And as you've explored the most profound of these philosophical questions, are we alone? Have there been sentient beings that have traveled by us or throughout the cosmos? You bring up these two principles that you maintain, modesty and novelty, and the concept that, here we are, you and I and everyone listening, we are but one of 9+ million species on this planet. We are kind of average. We're very frail. We don't live very long. We don't have superpowers. We can't regenerate like the amphibians. We can't hibernate like a tardigrade. Not very exciting overall. Talk a little bit about how these principles of modesty and novelty fit into both your thinking about how to explore, but also when you think in reverse about what others would be looking at us thinking.
Yeah, so first of all, I should say that these ideas that I will explain in a minute do not come naturally to people. The most natural thought that comes to mind when to people are that they're special, unique, and the world centers on them. And I saw it with my daughters when they were born. They tended to think that the world centers on them, until they went out to the street and met other kids, and they realized that, that they have similar qualities and they're not necessarily so special. And our civilization, there are many of my colleagues still believe that we might be alone in the universe. And of course, I see it as arrogance. Why would you expect us to be alone? I mean, there is no reason for that. We now know, actually, from the Kepler satellite, that about half of the sun-like stars have a planet of the size of the Earth, roughly at the same distance from the star. And that means that you can have liquid water and the chemistry of life as we know it. So if you arrange for similar circumstances, you're likely to get the same outcome. And if I had to guess, I would say that we are middle of the road kind of outcome. That in fact, we are not the sharpest cookie in the jar. We are not the smartest kid on the block. And, we tend to think that we are special, but we are not really. So that's a sense of modesty. And I developed it mainly by studying astronomy. You realize the universe is so big. There are 10 to the power 20 planets like the Earth around stars like the sun in the observable volume of the universe. And, that means that we are not special in any way, and we cannot be arrogant. We also live for such a short time, and how can anyone develop a sense of self-importance under these circumstances? I mean, the only thing you can develop is a sense of wonder, trying to figure out the bigger picture. But the way to maintain some arrogance is only by limiting your field of view and just, looking at yourself in the mirror or doing small things in your neighborhood that impress you or people next to you, but they are not really significant in the big scheme of things. And I think it's really important to maintain modesty. There is another reason for maintaining modesty, and that is our knowledge is very limited. It's just like an island in a sea of ignorance, an ocean of ignorance. So, even though professors in academia tend to brag, about their knowledge, and they get an ego boost whenever they discover something, most of the stuff we don't fully understand, and we don't know a lot. There is a lot to be discovered. And,
Sure.
given that, I think it's really important to be willing to take risks, to make mistakes, because science is a learning experience. We're not supposed to know the answer in advance. And Einstein himself made 3 major mistakes at the end of his career, in the last decade of his career. And, he was the most experienced in that phase. And he argued that black holes don't exist, gravitational waves don't exist, and quantum mechanics does not have spooky action at a distance. All 3 things were wrong.
Right.
And, that shows that when you work on the frontiers, you can never be always right. And I think approaching science from the point of view of a kid is the right attitude. The way I was thinking about it as a young boy and on a farm, just willing to take risks, make conjectures, and then test them, and not worrying so much about your ego and whether your image and how many likes you might get on Twitter and so forth. That is really irrelevant, because as many likes as you get on Twitter, you're really insignificant in the big scheme of things. So why bother? I don't have any footprint on social media, because my wife asked me not to have when we got married, but I don't regret it for a minute, because it gives me more time to think independently and not to worry about what other people think.
Absolutely. Avi, one of the cornerstones, let's say, to your area of specialty is this what I'll call looking for the cosmic anomalies. As a couple of years ago, when this interstellar object, which you termed Oumuamua, came through our solar system, and you highlighted, this thing was moving extremely fast with a weird orbit. It didn't have a wake of materials. In the book, you highlight the Venus phosphine gas work of Jane Greaves at Cardiff University. You also talk about some of these future civilization technologies like Dyson spheres and what they may look like. Talk a little bit about sort of the scope of what you look for in the cosmic anomalies that you that are most important for us to be looking out into the cosmos at.
Right. So once again, the natural tendency of people in academia, especially when they get tenure, is to promote their image and get more honors and awards. And the way to do that is by building an echo chamber of students and postdocs that repeat your words, and by that they get an amplified voice in the community and a better image. But it also goes in the direction of basically saying the same things that we already knew from the past, and not so that you don't make mistakes. I mean, the ambition not to get a better image is to limit the risk from making mistakes as much as possible. Now, I see it completely oppositely. I mean, the way I see tenure is giving you freedom to think, to go in directions that are potentially risky, but your job is secure. And that is the whole idea of making discoveries in science. You look for things that do not match what you expected, and these are anomalies. So in my view, science is a learning experience. We want to learn new things. We don't want to establish what we already know, and including, promoting ourselves so that we get honors. That's really not the purpose. Sure. And so to find new things, what you want to do is focus on the anomalies, on evidence that shows that nature behaves differently than we expected. And the classic example is quantum mechanics. Traditionally, physics was about classical objects, and then quantum mechanics came along and showed that the nature is very different than we thought. And took a while, and Einstein also resisted this notion that everything is probabilistic and you have this action at a distance in quantum mechanics. But it ended up being reality, and we have to explain, to accommodate to that. And reality is the one thing that never changes, even if you ignore it. So there is no point in avoiding it. If you see an anomaly, you want to understand where it's coming from and revise your notions. And it's just like a GPS system that recalculates when it gets to an unexpected place. So when we get evidence that doesn't match what we expected, we need to recalculate the way we think about the problem. So personally, I find the most interesting aspect of doing science is looking for anomalies, things that do not match what we expected, rather than focusing on what we already know and promoting our image. These are two orthogonal directions. So in cosmology, for example, the study of the universe, I worked on many anomalies. One of the recent ones is there was a report about hydrogen being very cold in the early universe, much colder than we expected. So we wrote a paper suggesting that perhaps it's coupled to the dark matter. That's another constituent of matter in the universe whose nature we don't know. And that is possible if, this coupling is possible if the dark matter has a small electric charge. So this is a speculation. We don't know what the dark matter is. So I consider that as an explanation to the anomaly that was reported. So that's an example. And in my mind, it was much more speculative than any of the discussions I had about Oumuamua. And Oumuamua is another anomaly. It's the first object that we discovered close to Earth that came from outside the solar system. And it was moving much too fast to be bound to the sun. So it's the first object that originated from outside the solar system that we witnessed close to Earth. And at first, of course, everyone thought, all the astronomers thought that it's just like the objects we already seen, observed within the solar system, the rocks, either comets or asteroids. Comets are rocks that are covered with ice, and the ice evaporates when they get warmed up as they get close to the sun. So the problem with that is it wasn't a comet. We didn't see any trail of gas behind it, but it wasn't really an asteroid, just a bare rock, because it exhibited some push away from the sun. And to me, that was an anomaly. We have to explain it. And there were other anomalies about this object that I describe in the book, about 6 of them. It looked very strange, unlike anything that we have seen before. And indeed, when other people tried to explain Oumuamua, they always had to contemplate, even if it's of natural origin, they had to contemplate something that we have never seen before, like a hydrogen iceberg or a dust bunny or something. But I suggested that it may be artificial in origin. It may be a light sail, a very thin object that is pushed by light, by reflecting sunlight. And the data was fully consistent with that. And we are developing the technology of light sails right now. And I'm actually leading a project that is developing that technology. And so if it's a light sail, it must have been sent by someone else from outside the solar system. And the question is who and why and what's the nature of this object. And it's sort of like the experience that you walk on the beach and you see mostly seashells and rocks that are naturally produced. And every now and then you see a plastic bottle. And you know that it's artificial in origin. I should say also that in September 2020, there was another object discovered, and that one was bound roughly at the orbit of the Earth around the sun. And it turns out that it actually came from the Earth. It was a rocket booster from a launch in 1966 of a lunar lander. And it also exhibited a push away from this by reflecting sunlight, without a cometary tail. And this one we know was artificially made. It was a very thin structure, hollow structure. And if Oumuamua is similar, the question is who produced it and why.
You just mentioned the Breakthrough Starshot initiative, which you are the chair of the advisory committee on. Here we have a fascinating project to develop this fleet of these light sails, as you were saying, trying to make the journey to Alpha Centauri, which is about 4 light years away, potentially traveling at 15 to 20% of the speed of light. So it takes about 20 to 30 years to get there, 4 years for data to come back. What type of data do you hope to receive in 30 some odd years from this, and what do you hope to find from that?
Right. So the data that we originally envisioned of getting was a photograph of the planet. It turns out that the nearest star is Proxima Centauri, that has a habitable planet. We didn't know it in advance when we decided about this project, and then a few months later there was this planet discovered in the habitable zone around Proxima Centauri. The star itself is 12% of the mass of the sun, so it's very light, it's a dwarf star, and it's much fainter than the sun. But the planet happens to be 20 times closer to the star, so it has roughly the same surface temperature as the Earth. It has a permanent day side. It's tidally locked, so it shows always the same side to the star. That side is warm, and then there is a permanent night side that is cold. And my daughters say that the real estate value would be the highest along the sunset strip, which separates the days, because you can build a house there and see the sunset forever, and it never sets. The star never sets in that strip, and it must be beautiful. At any event, we don't know if there is life on this planet, and the objective of Starshot was to perhaps fly a camera on a close-in orbit so that it can take a photograph of the planet and tell us whether it's green or desert-like, whether there is an atmosphere. That was the original idea, but the way I see it is that once we get to the point where we can launch a spacecraft that will reach Proxima Centauri within our lifetime, we might have other ambitions in mind. And also we can use the same technology to reach targets within the solar system very quickly, because the spacecraft is moving 1,000 times faster than the current technology, the rockets that we are using. So it's really a big leap forward. It will shorten the time to get to, for example, Pluto, from about a decade, 9.5 years that it took New Horizons to get there, to something less than a week.
Nice.
So it's quite remarkable. If we can launch things so fast, we could have chased, for example, Oumuamua. That would have been another way of finding more about it. So altogether, it's a new technology, and the idea is to use a very powerful laser that pushes on a light sail. So a light sail is just like the sail on a boat, which reflects a wind, but in this case, in the case of a light sail, it reflects light, and it gets kicked as a result, pushed. And the advantage is that the sail doesn't need to carry any fuel. It's being pushed by light. And also that it can, in principle, reach the speed of light because it's being chased by light. There is nothing else that can do that, no other technology. And it took us, when Yuri Milner, the founder of this project, came to my office at Harvard and asked me to chair this committee, I said I'll be glad to, but I first need to figure out whether there is a technology that can achieve that. And it took my students and postdocs and I about 6 months to recognize that only this light sail technology can achieve that goal. And I was asked to describe this technology to Yuri 6 months later. I was in Israel actually at the time, and just about to leave my hotel room to a weekend in the desert, in the Negev desert, the southern part of Israel, on a goat farm. That's where my wife wanted us to go, and then I was asked to prepare a presentation, and that was a bit surreal because we arrived to the goat farm. There was no internet connectivity except at the office. And the following morning at 6 a.m., I was sitting with my back to the office of that goat farm, and and typing into my laptop the presentation while looking at the newly born goats in that farm and contemplating the first project to visit the nearest star. And we announced it about half a year later in New York City. And it was very exciting. And we are now working on this technology and trying to figure out if it's feasible.
And if, as you say in the book, we make the Oumuamua wager, or the Starship fleet in 30 years, sends back something from around Proxima Centauri, whether it's some evidence of some intelligent extraterrestrial race, or, and we'll get into this in a little bit, sort of the astroarchaeology evidence that something existed there, quite advanced. You talk in the book about how psychology, philosophy, religion, education, all going to change. What do you think the next couple of years on Earth would be like after that data comes back and is verified?
Well, it really depends on what we find. First of all, I should say that it's very likely that life, any evidence for life that we would find, would represent a life form that looks very different from us. It's very different from the experience when you go on a date. When you go on a date, you look at the mirror, you imagine the other person, not being very different than you are, and that's usually the case. I mean, it could be a different gender, but overall, it's quite the meeting is not really surprising, and that's because we all share the same genetic heritage. But if you imagine life in a completely different location that had no connection to Earth, it could turn out very differently. You can start from the same soup of chemicals and end up in very different forms of life that would look shocking to us. Just to give you an example, on Proxima Centauri, this is a star that has a surface temperature that is half that of the sun, and that means that it emits mostly in the infrared rather than visible light. So our eyes adapted to visible light. That's the most common commodity, that's the resource that we have that illuminates the surface of the Earth. And that's why biologically we have eyes that are sensitive to visible light. But near Proxima Centauri, on the day side, you could have animals that have infrared eyes, very different than our eyes. They look very different because they're supposed to be sensitive to infrared. And then on the dark side, the permanent night side, there would be very completely other different animals that don't even use light. They just crawl on the surface. So I think it would be shocking for us to find life on another planet under different circumstances. And technologically, if we find evidence for another technology, most likely it will be much more advanced than ours, because we've been developing it for only 100 years. And so if you imagine what would happen in 1,000, I mean, our technologies evolve on a 3-year time scale, and in 1,000 or a million years, it would look unimaginably different from what we have here. So I think we can learn a lot by finding a technological relic. And that's why I think it's important to search for it. It's important to search for a message in a bottle, because it will teach us. It could be a shortcut to developing something that would take us a long time to do on our own. I mean, even though it sounds like cheating in an exam where you look over the shoulder of the person next to you to find the answer, I think it could be very beneficial. Also financially, instead of developing the technology in Silicon Valley or somewhere, if you happen to see it on the sky and copy it, or basically probe an object that you can later interpret as a new technology, that's a new path into the future. The other possibility is we will find dead civilization, by doing archaeology of space. Just as we dig into the ground to find civilizations that do not exist anymore, the same can happen in space. And then if you find them, that could be a lesson in history of how not to behave, so that we can avoid the mistakes they made and perhaps live longer.
It's interesting working along those lines. You know, you have in the book you have this section where you discuss sort of the comparison between discovering a primitive life form versus an intelligent extraterrestrial life, and you say either would fundamentally alter humanity's view of itself, but evidence of technological intelligence have greater impact. To learn that others, perhaps more intelligent civilizations preceded us, would force us to adopt a humbler attitude towards the universe and our accomplishments. And I wanted to just go in two directions with this one, if you would. And talk about for a minute sort of life in the middle, because sort of advanced but not, let's say, technological intelligence. We spend a little time talking about all the things we're learning about intelligence nowadays on Earth that we didn't really think about a decade or so ago. A case in point, say, the octopus, which, it's not this stupid mollusk that's just bumbling around the oceans, but it has potentially these 9 brains, and the way it thinks, we're just getting a view into. We have organisms on this planet that don't have brains, but undertake complex electrochemical communication. And we have species that don't have nervous systems, but certain amoebas that like to come together and make multicellular structures. If we found that the Oumuamua civilization burned itself out via some advanced technology, but left behind all these other intelligent species, but not technologically intelligent, that would be something too, I think.
Right. No, I mean, there is a fundamental question here that is embedded in what you're discussing, and that is whether intelligence is a benefit for survival or the other way around, because obviously we are also by developing technology, we develop the means for our own destruction, and we might change the climate and die, perish in a relatively short time. And, one can imagine that centuries from now, we won't exist anymore. However, if you had crocodiles or some very primitive form of animals on the surface of the earth forever, then perhaps that would have been longer lived. And that's an interesting question. And in principle, by finding life on other planets, we can answer this question. We can say whether intelligence is a benefit for long-term survival. Now, obviously, intelligence is a benefit because it offers you the ability to change your environment in a way that supersedes what random processes can do. So, random processes would never produce a robot or a spaceship. And in principle, that is a great advantage, because you can put on a spaceship the instruments that would allow you to replicate yourself. I call it Noah's spaceship, because there is this biblical story about Noah's Ark, where Noah was worried about the great flood and built an ark where he put animals to save them from the great flood. And you can imagine doing the same with a spaceship now to save the animals from extinction if a catastrophe occurs on Earth from a big asteroid impact or because humans misbehave and so forth. But you don't really need to put these animals on a spaceship. You can just put a computer system that is advanced enough together with a 3D printer that would reproduce life as we know it on another planet from the raw materials that are there. So in a way, intelligence offers the ability to survive in a different form. It's not necessarily keeping your own life or the life of our civilization, but being able to replicate it elsewhere and having a record of it that is sent out away from the planet that we destroy by misbehaving. I should say that I don't think that we are the most intelligent species possible. I think we have a big genetic, how should I say, misfortune where we fight each other. That dates back to our earlier stages of evolution, but we do, cooperation would be a much more intelligent approach for us to improve our life, the quality of life, and to, but instead, most of the time and money and energy are being spent on, destructive purposes. And you see that throughout history. I give in my book, I give the example of World War II, the Nazi regime that killed so many people and so much money was wasted. Whereas just before the war, Churchill wrote an essay about the search for intelligent life elsewhere. And if he was not bothered by the war, and humanity as a whole would invest the same funds that were used during the Second World War towards the search for life beyond the Earth, then we would be in a much better place. And that, shows a lack of intelligence in a way that, we're doing. I mean, racism, if you think about it, doesn't make any sense. Feeling inferior relative to another person just because of the color of the skin, or the ethnic origin. That makes zero sense, because the genetic making of all of us is almost identical. And how can you feel superior relative to? And why should you actually even desire to feel superior if all of us are in the gutters? All of us are, insignificant. As Oscar Wilde said, he said, all of us are in the gutters, but some of us are looking at the stars. And I think this is really my philosophy, that, we should aim at something higher rather than fight with each other on mundane things. Very often people say, oh, why even think about space? We have so many problems here on Earth. The point is, you don't want to embed yourself in those problems where there are things that would inspire you, it would give a meaning to your life. Why would you just focus on the problems that are, here and now, rather than have aspirations for something bigger?
Yep. As you were just bringing up the topic of what I'll call sort of our genetic colonization of space, in the book you talk about topics like synthetic biology, like we're just mentioning, Jack Szostak's work at Harvard. Should our genetic legacy be the first on that trip? And I bring that up because I had the opportunity last year to talk to Penny Boston at NASA, who was leading their astrobiology group, who loves to study all these wild extremophiles that we have on this planet that can live in nuclear waste, and the tardigrades, which can go into hibernation for years. Do the extremophiles and the tardigrades and all these other superpower organisms maybe deserve that colonization trip before us?
That might be, yeah. I completely agree with you. But again, all of them and us are just the consequences of some random processes that occurred on the surface of Earth out of a soup of chemicals. And you might even think that none of them represents the ideal thing that you can make. So I usually make the analogy with making a cake. You look at the recipes in a book, and out of the same ingredients, you can make very different cakes. And, if you imagine random processes making us, obviously, there are many other possibilities that were not realized, and maybe they taste much better than the cake we have. And so I would say that, we have, as you said, we have examples of organisms or creatures that have benefits relative to us as humans, for example. But I would go even farther and say that even they are not the optimal creatures that you can imagine. So I think the goal would be to figure out what would be the ideal thing that can survive the longest. Now, one possibility is that it's electronic devices. It's things made of silicon. Right? You don't want to make things out of biological material because they are short-lived. And if you make things of silicon, they can survive a very long journey in space and function and do whatever you want. And that's one possibility. But I certainly agree with you that we came to exist by chance, and we are certainly not optimized in any way. And that's one more reason to be modest. things can be much better than we are.
Speaking of that ideal species, and this is somewhat related, but over at in your direction of the world, over at Tufts University, I had the opportunity to spend some time with Mike Levin, who's developing these xenobots, these sort of brainless organisms derived from frog embryos, and we spent a little time talking about their potential sort of use in this interstellar exploration. And we got on this topic of sort of what he could foresee out there in terms of what the ideal Oumuamua might look like. And he came up with an interesting concept that here you and I, our genetic legacy on this planet is carried on by our germline, our sperm and egg, and so forth to the next generation. And with these xenobots and sort of the concepts it was based on, he said, it's highly likely that there could be species just like you and I that instead of using our germline, when we die, most of our body's still alive. The rest of our body could just serve as the basis for the next species. When you're hanging out, having dinner or working out or just spending leisure time, obviously you don't think of the cosmos all the time, but putting aside sort of the infrared vision and all, any neat ideas that come to your when you're daydreaming about the ideal Oumuamuan that we might one day run into?
Well, this is not my original idea, but there were these concepts of self-replicating probes for Neumann probes, for example, that even though they might be artificially produced, they can generate new devices later on. The most extreme example of that I thought of, and it's not in my book, but it's in a Scientific American article that I wrote a few months ago, was the idea, we have a fundamental question in cosmology, how the universe started. We know the universe started at a point in time, but what was there before? And an idea that I had, which is not a scientific idea because we don't really know what happened before the Big Bang. Einstein's theory of gravity breaks down at that point. Yep. But the idea that I had was, imagine that we get a good understanding of how to unify quantum mechanics and gravity so that we can get very close to the Big Bang and understand how to make a universe like our own out of the vacuum, out of nothing almost. And by irritating the vacuum. And then we can create a universe in the laboratory. So if you reach that level, and if that's possible, then you can imagine that the Big Bang was created in a laboratory of another civilization. And so it's basically just like making a baby universe. And that baby universe, if it supports life and intelligent life, that intelligent life would create another baby universe. So you have baby universes all the way throughout history. And that's one way of getting the Big Bang. It means that the umbilical cord of our universe was connected to another laboratory out there. And that's an interesting possibility that before the Big Bang, there was this laboratory. And they, of course, came out of another Big Bang that was in the laboratory of a previous civilization, and that can go forever.
Going back to your principle of novelty, if we look at now everything we've just been discussing from the viewer from outside, and you mentioned the Tokyo example from the edge of the solar system, aside from cleaning up our environment, is there anything that we should be doing such that the Oumuamuans or whomever that may be coming by at some point will make it easier to find us?
Oh, I'm not sure that we want them to find us because, when you enter a room full of strangers, you don't want to speak very loudly because you don't know the risk. We want first to listen. So I would think that we would like to, first of all, figure out who is in our neighborhood. Are they hostile or friendly? What are their capabilities? What are their ambitions? Before we do anything. Unfortunately, we were careless because for 100 years or so, we've been broadcasting radio waves. And the brightest signals that we sent out came from anti-ballistic missile transmitters, radars. And that kind of transmissions went a large distance by now. Over the last century, it went to a distance of 100 light years. And so there is a bubble of radio waves that we produced. And if there is one of the papers I wrote was to show that if there is a civilization with the same technology of radio telescopes that we have right now, within that distance of 100 light years, they should be able to detect us. Mm. And of course, it would take a while for them to respond to that. But given the experience that the natives of the Americas had when the Europeans came over, you know, I would caution us to be careful, you know, because it's not clear that it will be to our benefit to encounter such, especially a more advanced civilization. Now, it's also not guaranteed that they would do anything, because I can imagine a very advanced civilization like that decided to live in a cocoon and not really care about what's around them, and you know, that may make sense. Because any encounter that they have would reduce their quality of life. So they would basically close themselves off. In that case, we can still find about their existence, because, you know, they would still need to throw some trash. And just like investigative journalists that go through the trash of celebrities in Hollywood to find out about their private lives, we can learn about their private lives by looking at their trash. But we don't know if they have a closed habitat of that type, or whether they are dangerous to us, whether they might attack us if they decide to do so.
That would not be good. Avi, you are the science theory director for the initiatives at the Breakthrough Prize Foundation. It's a wonderful set of initiatives to allow these types of ideas to be worked on without all the, as you were mentioning earlier on, the fear of the egos and so forth. You have the big hitters, Sergey Brin, Mark Zuckerberg, Jack Ma, Alibaba. What can we do to have more of these types of structures set up? Because, you know, we still, you know, whether it's looking at the cosmos or finding out how to live to 200 or a list of these other major breakthroughs that we want to see, it always seems like there's not enough funding around, even with the people with this type of wealth. Any ideas of how we can get more of these folks to line up and start funding initiatives like these breakthrough ones?
Well, I think it's important to make science exciting, to address anomalies and questions that were previously not addressed. And the search for extraterrestrial civilizations is one of these frontiers that was underfunded. It's considered in the periphery of science right now, unjustifiably so, because, as I mentioned, you know, it's not speculative. If you have similar conditions to those on Earth in billions of planets within the Milky Way, you're likely to get the same outcome. So that this is not speculative at all to argue that we should search for signatures of those. And it's underfunded right now. So I think that is a natural place where more research is needed, and the public is extremely interested. But I would argue that it's not just a matter of fund. In fact, it's not funds. It's more to do with the practice of scientists right now, the psychology of scientists, and the fact that there is a lot of groupthink and traditional thinking rather than being brave enough, courageous to search for things that are different than what we have been doing until now. And so it's true that we focused in the past in astronomy on physical objects, objects like stars or galaxies or the dark matter, or these are things that do not have any life to them, and but that doesn't mean that the universe is not full of life, and that we just missed an opportunity to examine a very important aspect of the universe. We know that life is here, and so that is something that the scientific community should be more open-minded to. And primitive life in astronomy right now is, the search for primitive life is considered acceptable, but there is a taboo on discussing the search for intelligent life. And there is also a resistance to consider anomalies as if they signal something new. In the type of Oumuamua, for example, that when I suggested an artificial origin, there was a lot of pushback. And I remember coming out of a seminar on Oumuamua, and one of the traditional mainstream scientists, a colleague of mine, was saying, "Oh, this object is so weird, I wish it never existed." Which to me signals a problem with the way science is done. And it reminds me of what the basketball coaches often say, that you should look at the ball. They tell the team players, keep your eyes on the ball rather than on the audience. And a lot of my colleagues look at the audience before they say anything. And that's the problem, because we want to look at the evidence. The evidence is the ball. And we want to, if the evidence looks strange and unexpected, we want to examine it. We should not be worried about staying in our comfort zone. Perhaps our comfort zone is miscalculated. It's not the correct place to be, as in the case of quantum mechanics. Perhaps reality is telling us something new. And I see science as a learning experience, not so much as a way to boost our ego or to improve our image. So I really think that there is a serious problem right now in the scientific culture, in academia more generally, where people are just doing intellectual gymnastics to show that they are smart, not necessarily looking after the anomalies to figure out if nature is different than what they thought. And I think that has nothing to do with money. You can pump a lot of money to this community of people, and all they will do with it is reinvigorate the current thinking. And so there needs to be a change in the way that the money is allocated, and that encouraging people to take risks and to be creative, rewarding those that are embarking on anomalies rather than rewarding those that, currently the selection committees in federal agencies are led by people from the community. And very often what happens is, there are some conservative ideas in the community, and the people on the committee fund those proposals that support what is already known. And just examine the notions that are already known in greater detail, because we already know that that's our comfort zone. Let's continue to examine. There is very little allocated to innovative concepts and risky projects, because the claim is, why would you take risks when it involves taxpayers' money? The point is that we want to make progress. We want to learn new things. We don't want to get stuck. And moreover, the public is in particular interested in the search for extraterrestrial intelligence. So I think there are many reasons to rethink the way that funds are allocated within the current structure. Then, of course, to add on top of that, the funds from wealthy individuals, because right now in the private sector, there is a lot of wealth. And I think if one focuses on questions that are not addressed right now within the mainstream of science, that are of interest to the public, that we can address because we have the technology to address it, that's another path to take.
Avi, I have one other question for you. This one gets a little more philosophical and esoteric, but I'd love to have your couple minutes on it. Obviously, we talked about biologic intelligence. Artificial intelligence is a very hot topic nowadays. What about intelligence without life out in the cosmos. There's this in certain pockets of your world of cosmology and multiverse theory and so forth. This concept of, is this cosmos itself some type of consciousness that we have yet to really wrap our four-dimensional minds around? Give me your few minutes, please, on sort of grander cosmological consciousness.
I think this dates back to religious concepts about whether the universe as a whole implies something beyond, it's a metaphysics, going beyond what we see. Now, I'll just start by saying that to me, the surprising fact about the universe is that it's organized so well, that it obeys the laws of physics all the way throughout what we see, even though the laws of physics were derived by doing experiments here on Earth. And that's a remarkable thing, right? Because if you think about societal laws, each country has different laws. So obviously they're not universal across the globe. But moreover, people violate them all the time. Nature somehow respects, everywhere we can look, respects the same laws, and the universe is very organized. And that's remarkable. I mean, people take it for granted. It makes life easier because if you derive the laws here on Earth, you can use them at the edge of the universe and they apply as well. So obviously for a physicist, it's a no-brainer. It makes, you don't need to derive different laws at the edge of the universe. But if you think about it, it's quite remarkable. And also, when every morning when I look at my daughter's rooms, bedrooms, they are pretty disorganized, and the universe doesn't look like that. It started very simple. It was pretty much uniform, similar conditions everywhere. So, these facts are remarkable, and I'm not sure if they imply anything beyond, maybe some initial conditions that were special, and maybe it's just the nature of reality that, there are these universal laws. But I do think that that one should appreciate that, because otherwise we would never figure anything out. Imagine, things being different in different places. It would look very chaotic to us. And so that to me, from a secular point of view, that to me is the awe that I have looking at the universe. But then you ask, okay, what is there something beyond that? And so I will only go as far as Spinoza did. Spinoza identified God, or what he defined as God, with nature. He identified that with nature, and Einstein accepted that notion. And I do think that that makes a lot of sense with modern science. If you were to say that God is separate from nature and intervenes in our private lives, then it means that God is somewhat incomplete, that God needs to somehow interfere with nature, and therefore is unhappy with the way things are happening. And so it makes God a little bit, I would say, not not the ultimate entity that you can imagine. But so from a point of view of a scientist, I would say Spinoza's view of identifying God with nature would make sense. Now, you ask if there is anything beyond that. I would not, personally, I would not go any farther, because I don't have a good idea to offer. And I think everything beyond that would be speculative. In particular, the multiverse itself is speculative. We have no way of learning about it because there is no causal contact with that. And I have a problem with these speculative ideas that have no experimental test, because it's just like, well, I can think of two analogies, either being high on drugs, that you can feel happy, but it has nothing to do with reality, And the second is, thinking that you are very wealthy, and then without even checking your ATM, if you think you have a lot of money, you can be very happy and contemplate what you might do with it. If you wanted to translate that into action, you have to go to an ATM, and then you will find how much cash you have. And the ATM experience is just like doing experiments. So if you work on mathematical ideas that have no connection to experiments, no way of putting skin in the game, then you might be in the wrong direction and you wouldn't even know it. And that to me is very dangerous. You can spend your life working on string theory or on the multiverse or on extra dimensions and never putting any skin to the game, never testing what you're working on. And as a physicist, I wouldn't do that. As a mathematician, that's of course legitimate. Mm-hmm. But the whole definition of a physicist is trying to understand reality. Right. And I think a physicist should have what I call a Galilean oath, just like a medical doctor swears the Hippocratic oath. So the Galilean oath is that at least one of the ideas that a physicist is working on will be testable within the physicist's lifetime. And I think, unfortunately, this rule is not being honored by a lot of my colleagues right now.
I appreciate your input on that one. Avi, it's been a great time listening to you and wishing you so much success with these projects and everything you have lined up to move forward. For everybody that's going to be watching this episode on the YouTube channel or listening across the various podcasts, you've been listening to the amazing professor, Dr. Abraham Avi Loeb, Frank B. Baird Jr., Professor of Science at Harvard University, Chair of the Advisory Committee for the Breakthrough Starshot Initiative, Science Theory Director for all initiatives of the Breakthrough Prize Foundation. Pick up his soon to be available on Amazon book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth. Avi, thank you so much for taking the time out of your schedule to do this today. It was a real pleasure. And as we say, thank you for trying to create and helping to create a better tomorrow and a better future for all of us through your work. It was a real honor.
Thank you for your excellent questions, Ira. A pleasure.